Okay, good morning. It is Halloween, October 31st, 2018.
Oh.
Okay, so this is Algebra 2. Hopefully everybody is paying attention and not causing your sub to have to get onto you. Okay, super great. Yay, thumbs up. Okay, so solving system of equations using inverse matrices. Yesterday we did them using matrices and dimensions and things like that. Or, not dimensions. Determinants, sorry. Okay, here we go. You solve system of linear equations algebraically, and now we're going to solve a system of equations using the inverse matrix, even a 2x2 matrix today. And we're going to solve and write matrix equations for a system of equations. Actually, we're going to do that tomorrow, that part. Here's an example. So look carefully as we read this, this information here and the information that's over here. Lunch options. Basic brown bag includes a sandwich and 2 sides for $9. Here we have a lunch for 2, includes 2 sandwiches and 2 sides and 2 drinks for $16.50. And finally, the family option includes 4 sandwiches, 3 sides, and 4 drinks for $30.75. So with this information, we could write a system of equations, or we could use a matrix to solve this. So let's look at the top row right here. So we have one, if we look here, includes a sandwich and 2 sides. So we have a column that's sandwiches, a column that are sides, and a column that are the drinks. Then we have the cost of the sandwich, which is W, the cost of a side, which is S, and the cost of a drink, which is D. So if we use this information, and we know the cost of 1 sandwich, 2 sides, 0 drinks is $9. These are the answers. The cost of 2 sandwiches, 2 sides, 2 drinks for $16.50. And 4 sandwiches, 3 sides, 4 drinks, $30.75. So this information is set up a system of equations for you in matrix form, and that will lead us to figuring out how much each one of these things cost individually. Now, we're going to get to the third order, but right now we're talking about a second. We're going to do a second order. Okay. Now, hopefully I haven't overdone that. So some new vocabulary. Identity matrix. This actually you've heard before, I believe, but maybe not. Square matrix we have talked about before. Inverse matrix. We will be talking about that today. Matrix equation, and that's kind of what we were just talking about up there, but we're going to see that in action. Variable matrix, constant matrix. Okay. Now we're going to talk about the identity matrix right now. And you have an identity matrix for a square matrices. And if you remember, this is a 2x2, so a 2x2 identity matrix looks like this, and a 3x3 identity matrix looks like this. So that means when I multiply 2 things together and get the identity matrix, those 2 things would be the inverse of one another. I need a reminder here for you. If we have 2/3, what can we multiply that by to get 1? Jayla, what do you think? Yes, 3/2. Very good. I'm sure she'll do great. Okay, so 2 times 3 is 6, 3 times 2 is 6, 6 over 6 is 1. So the idea is, if we have a matrices, I'm going to make one up real quick. Okay, let's say it's 1, 2, 3, 4. First off, if we wanted to figure out what we could multiply this by, finish that up, to make this equal to the identity matrix of a 2x2, which is 1, 0, 0, 1, 1, 0, 0, 1. This is the identity matrix. Kind of like saying 1, you know, but they're not truly identical, but the idea is the same. This is the identity. This would be the identity of multiplying these 2 inverse numbers to each other and getting 1. We need to find what can I multiply this by to get the identity of this. Okay, so that's the idea. And we're going to learn how to do that today. There's a nice little pattern on here. Okay, now this is just telling us right here, this key concept, sorry. The identity matrix for multiplying I is a squared matrix with 1 for every element of the main diagonal. That means from upper left to lower right. And 0 in all the other positions. Notice this back up here for just a second. In the 3 by 3 matrices, identity matrix, upper left to lower right, and then zeros everywhere else. The same thing would hold true if we had a 4 by 4. We're not going to get that complicated here, but you could, because it could be a square matrix. Okay, so what we're saying is, we want to know where the identity matrix I, if you have some matrix A times 1, or I, which is the identity matrix, equals I times A, which equals A. But they're just telling you here what I is. It's the identity matrix, 1, 0, 0, 1. So if I multiplied the matrix A, B, C, D times the identity matrix, 1, 0, 0, 1, it shouldn't change anything. Okay, we should end up with A, B, C, D. Even if we multiply it forwards or backwards, we should get the same thing. And we can because they're 2 by 2. So the columns of the first one equal the rows of the second. Okay, now if we look down here, 2 n by n matrices are inverse of each other if their product is the identity matrix. Remember, that's what I was saying right here. 2 matrices multiplied together to equal the identity, this would be the inverse of this, and vice versa. But we need to figure out how to find that. Okay, so let's look at this. Okay, first off, we're not quite whoops, I'm getting carried away. Let me just move this instead. Okay, we're going to determine, yes? Yes, I'm trying to tape my class. Do you need them to come to you?
No, I just need to ask them whether they want soda or water at the Holocaust Cafe.
Okay, sorry everybody.
I read their names off, but they'll just tell me. But the soda, we don't know what it is.
Okay, you want me to just...
Random, whatever they get.
I don't have everybody that's supposed to be in my class. But I have Joel. He'll want what? Water. Megan?
Water.
Megan, Fox is water.
Okay.
Tyler, Spence is water.
Okay, hang on. Let me find this, because I have these in order. Okay, Joel is water. Tyler, Spence is water.
Sorry, everyone.
Who else do you have?
Megan Fox was water.
Okay, got her.
Grant is water.
Okay.
Water.
And Ben is water.
Okay.
I am water.
You are water. Okay. What will your husband want?
Well, it probably would depend on what soda it is.
Yeah, we don't know. It's whatever they give you.
Okay.
Whatever is there.
Let me text him in a little bit and I'll call you back.
Okay, sounds good.
Okay, okay.
Do you know where all these other children are?
Helping with the Ascend Junior
Okay.
or some seniors left.
Okay.
McKinley, I have McKinley. Soda or water? We do not know what soda.
Soda.
Soda for McKinley.
Okay.
Risk taker of living on the edge.
Okay, thanks.
Thank you.
Super sorry about that, everyone. Okay, so let's see if we can get through this. So here they're just wanting you to figure out if you know if these two things are inverse matrices, okay? So first, if we multiplied them together, they should equal 1, 0, 0, 1, if they're inverse matrices. So here they're multiplying them, and I know that you know how to multiply them because we've done that. So first row, first column is going to give you the answer to if you multiply and add the products, you're going to get the first row, first column element, right? So -4 times 1/4 is -1. 2 times 1/2 is 1. -1 plus 1 is 0. Okay, then first row, second column, -4 times -1/2 is +2. There it is. And 2 times -1 is -2. Add those together, it's 0. Well, already, I mean, you can go ahead and do the rest, and they did. Already you can see that you're not going to get 1, 0, 0, 1. So these two matrices are not inverse of one another. Okay? That is not what it looks like. So, A times B is not I, so they are not inverses. So now we have this one. It's one is to check these two. So 3, -5, -2, 6 times this matrix. 3/4, 5/8, 1/4, 3/8. So first we have to check F times G, and if that equals the inverse matrices, then we need to check G times F. Make sure it also equals the inverse matrices. So here they've done that. 3 times 3/4 is 9/4, plus -5 times 1/4, so -5/4. Add those together, you get 9/4 minus 5/4 is 4/4, so that would be 1. And I will let you do the rest. You know how to multiply two matrices. If you do not, go back and check. I believe it was lesson 3-6. But you can do it. Okay. Make sure, and they got 1, 0, 0, 1. So that worked. Nice little inverse or identity. So now we're going to check the matrix F times matrix, or G times matrix F. Okay, so 3/4, 5/8, 1/4, 3/8 times 3, -5, -2, 6. So first row, first column, right there. Adding those together equals 1. Okay, and you can do that. You're just conquer those fractions. You can do it. And then first row, second column, right here, gives you first row, second column answer. So -15/4 plus 38, combine that, you get 0, because that simplifies to 15/4. So -15/4 plus 15/4 is 0. And second row, first column right here, 0. Second row, second column right here, second row, second column. And that's 1. So 1, 0, 0, 1. So both of them equal I, so therefore F and G are inverses of one another. Okay, I'm going to move on because we kind of got lapsed right there with that drink information. And I'm going to try to get this in one setting. Some matrices do not have inverses, and you can determine whether a matrix has an inverse by using the determinant. Okay, now, this is how you could actually take, like the one that we had, I made up, what could I multiply right here to get this? And this nice little pattern is how you do it. If you have an inverse A, and if you have a matrix A, B, C, D, in mine it would be A, B, C, D, right? And this is the pattern that we would need to find. So to find the inverse of this, if we're going to say this is matrix A right here, okay? So to do that, to find its inverse, the inverse of A would equal 1 over the determinant of my matrix, which is AD, right? AD minus BC. You guys remember that. AD minus BC. Okay. Now, and times a matrix that it's coming from this, but it's arranged this way. D, opposite of B, whoops, I don't know why I put 5. That's getting carried away. Opposite of B, opposite of C, A. So this will give me the inverse that goes right here, if I do this pattern with my numbers. Okay. Now, but notice that if your determinant is the value, you can represent that as the straight lines or the DET. Therefore, if the value of the determinant of the matrix is 0, so if the determinant is 0, if this 2 by 2, we got a problem because we can't have it 0 in the denominator. Therefore, this matrix would not have an inverse, okay? All right. let's go to example 2 here, and then I'm going to do the one I made up if we have time. Please somebody tell me if you see that it stops recording, if you're paying attention at all, but if you're not, I'll try to watch, because there's a little orange deal right there. It's telling me if it's recording or not. Okay, there is some little interesting math history on the side there. I encourage you to read. I just am running out of time, so I'm going to move on. Find the inverse matrix of each matrix if it exists. So first off, we need to know if this determinant that goes right here, this is the inverse matrix of matrix P, if the determinant even exists. So you find the determinant 7 times -1 minus -5 times 2, which is -10. So -7 minus a -10, so that answer is 3 right there. So it does exist because it's 3. So a 3 goes under there. So, and they've already actually worked it out, so I don't know why they're working it out again, but anyway. So it's 1/3, and then you have to follow the pattern, D. So remember, this is A, B, C, D, so -1. So -1 goes here. Opposite of B goes here, so that's going to be -5. Oh, I'm sorry, it is -5. It's going to be +5. It's the opposite. The opposite of C goes here. That just turns into the opposite. And then A goes right here. See that pattern? Now, it's interesting because A and D just change places, and B and C just become the opposites. If you can remember that, that's great. If not, I would put it in a card or a foldable. Okay, so now, this would be 1/3, and then there's the pattern. You've already got it written. You could just put it there. This is fine to leave it that way, or you can multiply your fraction in, and it would look like this, okay? Now, by checking it, what they did was they just multiplied it together and make sure that it adds up to be 1, 0, 0, 1. And so they are identity matrices. And we're going to use this shortly in finding the solution to a system of equations, just like when we want to cancel something out to both sides, we do its opposite. Or like if you have 2x equals 10, you have to divide by 2. And so, or multiply by its inverse, 1/2. So here we're going to learn how to multiply by the inverse to get the identity, do it on both sides, and solve a system of equations. Okay, now, right here, B. So here we have this matrix. First off, you have to see, does it exist? Because if the determinant does not exist, then neither does your inverse. So -8 times 9 is -72. 12 times -6 also happens to be -72. So -72 minus -72 is 0. So the determinant equals 0, therefore the inverse of Q does not even exist. So don't go any further, just write does not exist. Okay? But I'm going to stop right there. This is going to lead us, I'll show you because it's still rolling. We haven't been 20 minutes yet, shockingly. We're going to roll into this type of thing, a system of equations, and we're going to solve it by using inverses. Now, this last lesson, we solved it by using determinants. Now we're going to solve it by using inverse matrix. Okay? And that's where it's going. I would love for you to read ahead, but tonight's homework, as hopefully you already know, you are going to go online, and if you have time, maybe your sub could show you and just do it together. Open up, and you can help them do that. Open up your book, and you're going to go online and watch example 1. It's not this specific example, but it's one like it. And you're going to do example 1, personal tutor, and you need to take notes for example 1 and example 2. Okay? And so that is it. I hope you have a good time, and I will see you later today if you want to wave at me in the hall. Okay. God bless. Bye. That's right. McKinley says bye.